In the previous video, we have discussed about rabbit test. Friends, yet we have seen that comparison test of the first kind, comparison test of the second kind, limit form of the test, comparison test, Cauchy's root test, D'Alembert's ratio test, Rabbit's test. Now we discuss about logarithmic test. Logarithmic test. If summation un is positive term series such that limit of n into log of un divided by un plus 1 equal to L, then the series converges if L greater than 1 and diverges for L less than 1. So you can see that this series do not have the third condition. It is do not make any statement about L is equal to 1. It says about only when L is greater than 1 and L is less than 1. It converges for L greater than 1 and diverges for L greater than 1. We have seen that the Rabbit's test is a powerful test than the ratio test. We have in the example we have seen that where the ratio test fails, by using the Rabbit's test we get a definite result. Here we have one more important test of infinite series, and that is logarithmic test. So as usual we consider here L is greater than 1. Then we choose that this L minus epsilon will be greater than 1, and we call this L minus epsilon as a alpha. So what is given here? We have limit n into log of un divided by un plus 1 equal to L. So by the definition of limit, for epsilon greater than 0, there exists a positive integer m such that this term mod n into log of un divided by un plus 1 minus L is less than epsilon. Now less than epsilon for all n greater than equal to m. Again similarly L minus epsilon is less than n into log of un divided by un plus 1 is less than L plus epsilon. So we are discussing about the term L is greater than 1, and we have taken L minus epsilon equal to alpha. So therefore we consider the second part of this inequality, alpha, L minus epsilon equal to alpha. So instead of L minus epsilon I am writing here alpha. Okay, so alpha is less than n into log of un divided by un plus 1, or here dividing by this term, dividing by n, we can write log of un divided by un plus 1 is greater than alpha divided by n. Now taking exponential on both sides, so exponential and log will be cancelled and we get un divided by un plus 1 is greater than e raised to alpha divided by n. Friend, we know that the series 1 plus 1 divided by n whole raised to n tends to e. So, this term 1 plus 1 divided by n whole raised to n is always less than e, and it is less than e. That means if we consider 1 plus 1 divided by n whole raised to n whole raised to 1 by n is less than e raised to 1 by n, and you can see that this n get cancel and we get 1 plus 1 divided by n is less than e raised to 1 divided by n. Taking alpha power on these both sides, we get 1 plus 1 divided by n whole raised to alpha is less than e raised to alpha divided by n. Now come to this term un divided by un plus 1 is greater than e raised to alpha divided by n, but e raised to alpha divided by n is greater than 1 plus 1 divided by n raised to alpha, right. So, here we have un divided by un plus 1 is greater than n plus 1 raised to alpha divided by n raised to alpha. Now, let us take the series Vn as a 1 divided by n raised to alpha. Now, here you can see that if we take Vn equal to 1 divided by n raised to alpha, then Vn plus 1 equal to 1 divided by n plus 1 raised to alpha. Now, here from this, here we can write this term as un divided by un plus 1 is greater than Vn divided by Vn plus 1. Now, we can apply the comparison test. By comparison test, this series is converges for alpha greater than 1. Here alpha is greater than 1, therefore, the series is convergent. Summation un is a convergent. Summation Vn, that is 1 divided by n raised to alpha, alpha is a greater than 1. So, this is a convergent series, and hence by comparison test summation un is also convergent. Summation un is also convergent by comparison test of the second kind. Now, let us see the example of this. We can similarly we can prove the second part of this series, logarithmic series. Okay. Now, we see example of this logarithmic series. We will test the convergence of the series. Test for convergence. Test for convergence. The series 1 plus x divided by 1 factorial plus 2 square into x square divided by 2 factorial plus 3 cube x cube divided by 3 factorial plus for x greater than 0. If we ignore the first term, we can easily write the un term. Ignoring the first term, as there are infinite terms, we will ignore the. We have n equal to, what is n? N raised to n into x raised to n divided by n factorial. Here we get un. Now, un plus 1 equal to n plus 1 raised to n plus 1 into x raised to n plus 1 divided by n plus 1 factorial. Now, un plus 1 divided by un plus 1, n plus 1 raised to n plus 1 into x raised to n plus 1 divided by n plus 1 factorial into un. Take the reciprocal of un here, n factorial divided by n raised to n into x raised to n. Now let us simplify this. Here we can write this as a n plus 1 raised to n into n plus 1, and here n raised to n, x raised to n plus 1, and here n factorial divided by n factorial into n plus 1 into x raised to n plus 1 divided by x raised to n, that will be x. Now you can see that n factorial get cancelled, n plus 1 get cancelled, and we remain here this term n plus 1 divided by n whole raised to n into x, and this is in the limiting case. If we take the limit of this, limit of un divided by un plus 1 equal to limit of this 1 plus 1 divided by n whole raised to n into x equal to, this is nothing but e into x. So by ratio test, the series converges for ex less than 1 and diverges for ex greater than 1. That is, the series converges for x less than 1 by e and diverges for x greater than 1 by e. Now what about x equal to 1 divided by e? When x equal to 1 divided by e, we have here un plus 1 divided by un. Look at this un plus 1 divided by. Now what we have the result? The series converges for which x? The series converges for x less than 1 divided by e. This is the convergence, and diverges for x greater than 1 by e. Let us discuss about the convergence at x is equal to 1 by e. X is equal to 1 by e. Then here you can see that un divided by, I am writing once again, un divided by un plus 1, this is equal to un divided by n plus 1, that is the reciprocal of this n raised to n divided by n plus 1 raised to n into 1 by x. But here we have taken 1 by x equal to 1 by e. So this will be n raised to n divided by 1 plus n raised to n into e. Now n in let us take the log of this, log of un divided by un plus 1 equal to, here log of n divided by 1 plus n whole raised to n plus log of e. Log of e is equal to 1. So this is equal to 1 plus n into log of n divided by n plus 1, log of n divided by n plus 1. Now log of n divided by n plus 1, so this is equal to, now here this is equal to 1 plus n into log of, we write this as 1 divided by 1 plus 1 by n equal to 1 plus n into now log of 1 minus log of 1 plus 1 by n. Okay, so log of 1 equal to 0. This is equal to 1 plus 1 minus, now minus n into log of 1 plus 1 by n. Now using the logarithmic series. Okay, so let us take the limit of this term. This is equal to, now this will be n into, let us take the limit n into log of un divided by un plus 1 equal to limit n into 1 minus n into log of 1 plus 1 by n. This is equal to limit n into 1 minus n into, now 1 divided, apply the logarithmic series, 1 by n minus 1 divided by 2n square plus 1 divided by 3n cube plus 3n cube plus minus like this infinite terms. Now here multiplying this n, multiplying by n in the bracket term, you can see that if we multiply, this is equal to limit n into 1 minus, now we are multiplying, so we get here 1 minus 1 divided by 2n plus 1 divided by 3n square plus like this. Okay, now you can see that this one and this one will get cancel, cancelling this term. This is equal to, let us cancel this, this is equal to limit n into, here minus become plus, so 1 divided by 2n, 1 divided by 2n minus 1 divided by 3n plus like this. Now again we have this n and this n cancel, here this is n square, and we get limit of 1 by 2 minus 1 divided by 3n plus all the remaining term contain n, and therefore in the limiting case all the remaining terms will be 0 and we get 1 divided by 2. As 1 divided by 2 is less than 1, this series is a divergent. Since by logarithmic test, when the limit L is greater than 1, the series is convergent, otherwise it is a divergent series. So here L we get a 1 by 2 limit which is less than 1, so the series is a divergent series, for which value x is equal to 1 divided by e, and hence the series converges for 1 divided by e and diverges for x greater than and equal to 1 by e. Friends, here thank you for watching.